Hello, everyone, and welcome to this week's episode. You might be wondering right off the bat why Spectre isn't doing that intro, and unfortunately, this week Spectre won't be on, so I will at least be trying to do this solo. Will probably mean that this is a shorter episode. Won't really have much back and forth discussion with myself. But this week we've got a few somewhat interesting vulns, a little bit of drama, and yeah, I'll just jump right into it, I guess. First, it looks like some Twitter issues. First one here, I was going to talk about the Orca security issues. They reported a couple vulnerabilities in AWS. Had their tweet up. Doesn't look like it's loading right now for me. Oh, refreshing work. So yeah, Orca security reported two vulnerabilities. This is the little bit of drama. There's some questions about how damaging these vulnerabilities are. AWS or some individuals at AWS have replied on tweets or made tweets indicating it may not be as impactful as Orca security is claiming. You can kind of dig into some of those tweets yourself. The claim here is both these vulnerabilities essentially compromise internal services. So one of the vulnerabilities, person they'll cover, breaking formation, is in CloudFormation, one of the AWS services that you can use. And apparently they're able to compromise, at least somewhat, one of the internal service accounts. Unfortunately, so the other issue is in AWS Glue, where they're also able to compromise the internal service. The one in CloudFormation provides a more of a file request or a SSRF situation where they're making this request as an apparently highly privileged account. They demonstrate that by having this internal AWS service account make a request to one of their S3 buckets. So it seems like a high impact thing. I'm not really going to weigh in on those claims. What I want to come on here is actually with Orca Security putting out this announcement that they are announcing these two critical O-days in Glue and CloudFormation, and they're going to provide, their research pod discover these issues, and they're providing full technical details. This is really just a little bit of a rant for me, but I get it when a company wants to put out like a fluff piece to advertise themselves. This is their business model. They want to get clients. I get it. I'm okay with that. I try to avoid it. But when they go and call this full technical details, that just kind of, I want to call them out for doing this because this is not full technical details. To take a look here at the issue in CloudFormation. Effectively, all they say about the internal details about this. Let me see if I could find the exact quote. Yes, leveraging an anomaly in the way CloudFormation renders templates allowed us to trigger an XXE vulnerability. That is the entirety of the technical details they provide. So not a lot to go on here. There's an XXE. So that's XML external entities. Basically, you can include an entity, it'll make a request off. That'll let them read files off the server, giving them the privileged credentials that they were then later able to use. Very similar sounding issue when it comes to the cloud, or not CloudFormation, the AWS Glue issue. This time, though, it's like, here's the technical overview of the superglue vulnerability. During our research, we were able to identify a feature in AWS Glue that could be exploited to obtain credentials to this privilege. Well, they go through a little bit more work on this one. They end up talking a little bit about escalation from they have this role they can impersonate and go on from there. But that's all of the technical details were provided. It is a feature that could be exploited. I'm okay if they want to do a fluff piece, but this has gotten a lot of media attention also, getting put out there as though they put out technical details, and this is not technical details. This is It's a fluff piece, and I'm okay with that. It just really annoys me when they call it technical details. Oh, so I mean, you can make your own claim as, or you can do your own research as to whether or not this is as damaging as they claim. So in this case, they seem to be able to escape from the glue service and are able to gain kind of administrative access over an entire AWS region. Of course, being security researchers, they didn't go and test that by like compromising random people. They used their own accounts. They seem to have tested this, so they make that claim. Although there have been some replies from people at AWS who may or may not have actually been involved with the triaging and fixing of the issue, so don't have all the same details that those who found it do, claiming that even with that level of access, they wouldn't have been able to compromise other users. There are some questions there. You can basically just check Twitter for that little bit of drama on it. I don't know. I mean, we only know what people are saying, so I'll let them kind of decide that. I tend to side with the researchers, probably have a decent idea about what they were able to do. And, AWS may have had some design features that would make it more difficult, but I kind of lean towards the security researchers having a better understanding of what their vulnerability was. But again, there's a little bit of drama around that. Coming into our second issue is what feels like a bit of a regular here. This time we're seeing mermaid.js come up yet again, or mermaid coming up yet again. We have talked about multiple cross-site scriptings in this before. I think there's been at least 2 other episodes where we have had a cross-site scripting issue in mermaid code. This is yet more of the same. And I kind of want to cover it because it is more of the same. It is just more mermaid, which I believe is being used with either GitHub or GitLab. Or used internally by it. So you can include these mermaid diagrams in. Basically what mermaid is, if you're not familiar, is you can write markdown or markdown looking code. It's basically an extension on markdown to have a graph or to have a pretty looking graph rendered onto your page. Or diagrams, I think, more generally, more so than just graphs, but that's your idea. So in that markdown, you can get cross-site scripting. This is also where this week's Spot the Vuln comes from. And so the first issue is pretty laughable, and it's a common issue, so I just wanted to shout it out again. It's this idea with the sanitize URL function. What ends up happening in this is it just takes the string that they want to sanitize, replaces the ampersand, replaces your left angle bracket, and JavaScript, so you can't make it a JavaScript URL. You can't open a new tag. The way they're using this in rendering the HTML itself, quotes don't seem to be an issue in this case, though it is going into an attribute. They're applying that directly, like they're modifying the attribute itself, so it's kind of like a prepared statement, not an issue in this case. So they're doing something right, escapes. I would question whether or not they should be doing more when it comes to other options beyond JavaScript. This is just blocking those JavaScript URLs, requiring that click, but beyond just that. But what they're not doing is running this multiple times. So they replace, JavaScript with an empty string. So you can kind of do the classic blacklist bypass technique, which is, JavaScript script. So then it removes the JavaScript in the middle, and that leaves you with JavaScript as your string kind of left to escape. Straightforward issue. We have seen this so many times, and I'm always surprised that, we keep seeing this because somebody's writing this thinking, yes, I'm going to take care of some of these excess issues writing this, and then they're still making these very simple mistakes. The second issue covered in here relies upon that same thing, but it's in this add links. So you have 2 issues at play. First issue at play is the HTML labels feature, which one of the earliest issues we talked about was being able to bypass or turn on HTML labels when it shouldn't be, providing it inline. There's a little bit of trickery with that. Now, this HTML labels is basically saying, like, do we support some HTML inside of our labels for the graph, for the diagram itself? So in this case, there's also kind of a separate little display that's going to show all of the links. It's like this little pop-up that'll show up, and it'll show all the links in the diagram, so kind of have that separate display. That relies partially upon the sanitization happening earlier. So in cases where HTML labels are on, which still does a little bit of work to try and prevent arbitrary JavaScript, it's allowing HTML, but not just any old JavaScript. But because when HTML labels is off, that sanitization doesn't happen. So when it comes to the links being inserted later, it's going to insert that unsanitized link into like this little database or its list keeping track of what links are there. And then later, when it goes to generate the link area, that's where you can then gain cross-site scripting because it hasn't been sanitized yet. It does require that HTML label thing. I don't know how common that's going to be. It feels like that is a little bit of a security boundary, and it does also rely on that sanitize URL function. So when they fix this sanitize URL function, even with that issue, they still wouldn't be able to, assuming they do this properly, they wouldn't be able to get cross-site scripting. Third issue, I don't even think it's a separate issue, really. This first one is in the links key. This one now, the second one is when you use a link. It's doing exactly the same thing, same process. It's just an add a link instead of add links. Same issue, really straightforward cross-site scriptings. It's just, like I said, it's so surprising to me to still see this idea of, removing something and, just not running it recursively. Perhaps if they did just escaping of it rather than removing it would have kind of saved them here. So kind of a better option, but it just always stands out to me to keep seeing that because this is something that, I saw when I was a kid. Being like 10, 11, this was still was rampant then and still rampant now. Second issue here is I'm going to call it the session hijacking. They say pre-auth RCE in Moodle. And this is in Shibboleth. Now, this is the bad code of our title for the week. Because it is part of the blame is going to go on PHP for how they operate. I'll get on that in a bit. Part of it is just bad code. They should have found some other way to do this. So the issue here, and again, I'm mostly focusing on the session hijacking. I'm assuming basically once you hijack an admin account, you're able to get code execution. That would kind of be what seems to be the case because they don't dive too much into the actual how they're getting RC here, but they do have a previous post about that. Anyway, so this Shibboleth plugin, which is part of the main code base for Moodle. So I'm not sure if this is how exactly this is a third-party plugin versus something else. But the idea of this plugin is it's like a SAML authentication provider. So it'll create the endpoint so that you can have like the identity provider, do callbacks and logout, stuff like that, which is the one that matters here because its logout does one thing really, really stupid, basically. When it's storing the sessions in a database, and it receives from the identity provider the request to log out a particular user. So this is not like your standard logout where you go and, upper right corner, whatever it is, and click logout on your user account. That's implemented by Moodle, a little bit separate from this. This is the Shibboleth's kind of session tracking itself and tracking when somebody logs out, if they're SAML provider, it'll log them out there. Makes sense that it has to be there. So what they end up doing here in the particular case where they're storing it in the database, they do it a little bit differently for files. They will start off just selecting all of the user IDs from the session table. And get all of like the session data from there. Makes sense. They'll iterate over all of those sessions. And then they do the questionable thing. they will call session decode on every session that they're reading. Now, what that does is and this is where I put a little bit of blame on PHP, is session decode will take the session, serialized session that you provided, and it'll place it into the session super global. So you can then go ahead and like read that out, or read what's going on with it. Basically it'll deserialize it into the session global. So that session super global is how you're tracking what users logged in or anything like that. It'll read it into that value. The issue there being then that for that slight period of time, you're actually logged in as every single user as it iterates through this list. It's effectively logging you in as every user. You have a very short window to actually take advantage of that. Because it is actively iterating, so maybe you can get a single request in, but then that session or the session superglobal might be changed out from under your request. So it has a very short window, but you can definitely do something with that. But the bigger issue here is also once they finish, so they're iterating through all the users, and when they find the right session ID, the session that matches what they're looking for, they'll log them out. So kind of doing the job, and then they keep going. They keep iterating, and that's where the issue comes in, because you're left with that dangling session decode that then once this is all run and they've logged out the one matching session ID, after that, you're still left with your active session that hasn't been killed and doesn't get destroyed. So whoever the last user is in the session list, you're now logged in as them. So that's where the session hijacking comes in. Just really stupid code. Part of it, though, part of the blame does come down to PHP on this one, because PHP doesn't just use their standard serialization when it comes to sessions. What PHP does is, so they use the standard serialization, but then they delimitate a bunch of values using the pipe character. I believe that's the main difference, but it is slightly different, so you can't just pass that data into it. You've got to do this extra little bit of processing on it, which just makes it basically the only way they expose for you to decode this session data is through this session decode function. There's not another option for you to use there. So the fact that they don't expose that is what do you expect developers to do? So it's just an unfortunate scenario for the developers who really don't have a lot of other options besides writing their own parser for it, which is what the patch ended up doing. I will pull the patch up here. The patch effectively just gets the user session through their own implementation of unserialized session. From there, most of the code pretty much remains same since they're not changing that session super global anymore. They won't have that dangling session anymore. It's an interesting scenario to me that they were even doing this. But really bad code. Stupid thing to kind of choose to do, but at the same time, as a developer, you just look how do I get this session? I can kind of understand it a little bit, but the fact that you have, no matter what, you basically are left with that race condition when using session decode just makes it such a bad code issue, I guess. Yeah, I'm not sure what else to really go into on that one. The RC, like I said, isn't included in this. It seems to be included in part 1, which was back in July, so we haven't covered that on the podcast before. I guess one other noteworthy aspect of this is that, let's say, that last user isn't somebody privileged, so that dangling session that you get, they're not privileged. You can then use Moodle's logout to remove that session, and repeat the attack until you get the actual account that you want. So you can basically get any user as long as they have an active session, which it's bound to happen eventually. You can gain your administrative access on Moodle. Moving on to our last topic here, a little bit of research. This is from Team 82, and I believe their name's Sync, SNYK. We've covered some things from at least Sync before. They put out a research paper here about URL parsing confusions. And it seems like part of this started with the Log4j issues, where Log4j had one of the initial patches there had introduced the allowed LDAP host as a. I'm not sure how it was exactly provided. If it was argument, I assume it was like environment argument, like being pulled out of somewhere else, not provided in line. But it would include by default 127.0.0.1 or localhost as an allowed LDAP host. So when it does the LDAP lookup, it's going to look up the host and be like, is this okay? Are we allowed to access this? And one of the bypasses was to include the fragment. I'm not sure what page this is on, so I can't pull it up super easily. But one of the payloads there was effectively to do like LDAP : localhost, and then include the pound symbol or the number sign .evilhost.com. And what would end up happening is when the pre-URL parser, yes, as Rudamal said, hashtag would probably be a more common way of putting it. Slipped my mind. I wish I could. I should have taken note of which page everything was on, but creates a fragment part of the normal like HTTP URL. What ended up happening with this LDAP case is when the Java code in Log4j try to validate the host would look this up, it would parse the host name as the 127.0.0.1. And it's like, okay, this is totally fine. But what would end up happening is LDAP URLs are not the same as HTTP URLs. In an LDAP URL, that hashtag has no impact. It is not a special character at all. So when the actual LDAP lookup would happen, that LDAP lookup would treat the host name as the 127.0.0.1 hashtag.evilhost.com as like that's the domain. So now the domain is evilhost.com, or the authority is evilhost. And that was the bypass there. So that was basically, you had two URL parsers. One treated the authority or the host as localhost, the other one as evilhost. So this whole paper is just looking at 5 different types of mix-ups that can happen. They looked at several different URL parsers. This is across several languages. So obviously Java, they looked at like URL, lib, and Python. They looked at curl, of course, wget, various types of URL parsers, and just looked at what type of confusions can happen where they either don't match the spec, or there's a little bit of discussion about the RFC 3986, which is your RFC for URLs, and the WhatWG. Basically all the browsers follow the WhatWG spec, the working group for the browsers, versus not following the RFC, and some of the differences there. And they came across basically 5 different confusions that can happen. First one, the first one being a scheme confusion. So that was effectively, in this case, when I saw that title, I was expecting this to be along the lines of a just a weird scheme being used. What it actually is when they remove the scheme. So the earliest RFCs for URLs did not have any mandatory parts. So if you just provided it a google.com/abc, that was fine. It would just either imply or it would make some assumptions about what the scheme was. In RFC 3986, however, the scheme is the only mandatory part of the URI. So what they found was URL lib and URL parse, or its URL parse function, URL split, would give an empty host and it would treat basically the entire URL as the path. But what they found is some would parse it as the host. So like curl would treat that as kind of a human error, and it would parse that as just the HTTP request, and it would parse the rest as normal. Kind of makes sense why curl does that. But that then means that if you have some that's looking on a blacklist for those host names, because URL parse would, or URL libs URL parse would treat that as the path, or would treat everything as the path, you would then be left in the case where, well, the host isn't in this blacklist, so you can make the request. So you kind of have those parser differentials that you can take advantage of. Next issue they found was slash confusion. That's just where you used a non-standard number of slashes, a thing like http://google.com. The spec would indicate, so the RFC would indicate that after the scheme, you get the authority until you hit one of those special characters, like the slash, like question mark, or the hashtag. Until you hit one of those. So since you now have 3 slashes, you end up being left with basically an empty host again. And some other things, such as the browsers, will all normalize that and ignore those extra slashes. Curl will ignore 1 extra or 1 too few. So curl seemed to have the really special case there. Browsers, of course, it's trying to handle like that human input error. So if you do // over and over, browser still understands it. Problem there is, any sort of redirect that hits the browser, the location header will also respect that. Third issue was /, so that's just using a / instead of a slash. And this one is interesting because it comes out of the difference between the RFC and the WhatWG specs. In the RFC, a / and a / are entirely different characters and should not be interpreted as one another. However, the browsers, which follow the WhatWG spec, those say that the / and / are the same character. So while URL lib, the regex they use will support backslashes in the authority. Other than that, the it generally respects the spec. So you end up being left with basically if you toss a random / into your URL, you'll have different parsing. Sorry, I'm not following along in the actual video here. Since I'm the only one on the stream, it's a little bit harder to find where everything is while I go. But I thought that one was an interesting one again just because of that spec. But the most interesting issue or confusion that they found was actually the URL encoded data. I feel like this is something I knew could be done and then just kind of forgot as like one of those novelties, like when you do IPs in octal format or something. So you just provide a number as your host or something like that. So apparently you can use URL encoding. I think of URL encoding as part of either the fragment, as part of the query, maybe as part of the path. But I don't really think of URL encoding as part of the host name. Maybe I should, because that makes sense that it's there. But basically, you can use URL encoding everywhere. I think the only place where you can't is in schemes. So what they ended up finding here was something like URL lib again. The parse URL would, when it would parse the URL out, it would not decode the URL encoding. So you would get this URL that's, %68, percent whatever. You would get all of that back. It's like, here's what the host is. But when you made the actual request, or if you use the request library or anything else, it seems, they didn't compare with too many others, it would resolve that. So it would go to the proper domain. The example they used was URL encoding Google, I believe. So what would end up happening there is you have that differential where parse URL gives you this URL encoded domain, and you check that against your blacklist, or perhaps something else, but you check that, and it doesn't match, but then the actual request ends up resolving to somewhere, in a sense, completely different. Not really completely different, but most developers aren't really going to be thinking about needing to do that URL decoding in there. The last type of confusion they had was the scheme mix-up, and this is where the log4j issue comes in, where I mentioned the difference between an LDAP URL, which doesn't include that fragment, doesn't care about the hashtag character, and that just is part of the actual authority or the host. There are other ways where, HTTP scheme is parsed one way. Other schemes may cause parsing to happen in another way, so parsing it always using the HTTP parser may not be sufficient in some cases to figure out where the actual implementation is going to take it. They do also cover a real-world vulnerability with this, or I think two of them, Ruby on Rails clearance plugin, taking advantage of the multiple slashes. I didn't find those as interesting as just the overview of here's what some of our research uncovered. Because I do think on the whole, like, this is interesting when it comes to doing like your bug bounty, any sort of bug bounty work. This is just giving you ideas for how do you test for these issues, what type of issues are actually seen. And they do have a decent kind of overview page here. Summary, which just shows like this library did this thing on this setup. When it comes to testing, you don't always know what's actually being used, so you just kind of have to try everything and see if a problem comes from it, rather than knowing. If you do know exactly what's being used, great. But most of the time, it's just going to be add these to your test case, or if you use some sort of web fuzzer, just add these test cases in there. That's basically all that I'm getting from this. Add these as test cases. They are interesting scenarios to be aware of. Not necessarily something I would always remember, but I mean, it's good research. It's something that we've seen these issues before. I'm not sure if we've covered them on the podcast, but like I've seen CTFs based around this idea of differences in the parsers. So it is nice to kind of see it all laid out rather than just one of those tricks that I've known about but don't really have it formalized. And out of chat now, I do want to take I guess one of our pro tips here is if you're worried about memory leaks, just free your memory before you use it. And Rudimal mentions I've seen some projects actually using the never free way. Actually works pretty well if the program doesn't live for long. And I just want to kind of jump on that a little bit. Enough, I mean, technically, like, you're not going to have a use after free if you never free. Like, that is a true statement. We'll sometimes joke about, like, just don't free everything. A lot of programs have a lot of memory. It is a valid way to go about it in some scenarios. The other thing is only using stack-based allocations is another philosophy that I've seen used. Obviously, you have to be wary about, like, returning pointers, but you can write it in basically an allocation-free way. Or you can try to. Not everything can be done that way, but it does exist. It is worth being aware of. I mean, as silly as it sounds, like, yes, in some cases, not freeing memory can actually be an effective way. Actually, I guess that reminds me, we covered a research paper about it was a forward only allocator, I think, something like that they called it, where the allocator would never reuse memory. effectively, the addresses would only go up because you have such a huge address space when it comes to 64 bits. Just keep going up, never look back, never reuse anything. It's another way of kind of avoiding the use app free, even if you do get a use app free or get a invalid free, basically dangling pointer. You're just left in a scenario where that address is just never getting reused. It avoids a situation like it is a little bit of a joke, but yes, sometimes those jokes have a nugget of truth. So just wanted to toss a couple comments on that. I realize this is our bounty episode and not our binary one, but this was the URL parser confusion was the last research topic for this week. So I guess I will leave it there, and I'll mention the solution to this week's Spot the Vuln. Technically, I did actually cover it during the mermaid topic, so you can jump back to that. Or we'll be covering it tomorrow, or I'll be covering it tomorrow on at our 7 p.m. binary episode. We'll be back again next week at 3 p.m. for these bounty style issues. As usual, videos will be up on YouTube tomorrow, and the audio only podcast will be available on all the usual podcast platforms: Apple Podcasts, Google, Spotify, Podcast Addict, whatever you use. We'll try and be on there, or just hit me on Discord and let me know that we're not on some platform, and I'll see about getting it added to there. So thank you guys for listening, and we'll see you next time.